significant figures quiz. Hopefully that went okay. And today what we are going to do is we're going to break up into some groups, and we will work on some mole conversion problems. So I just want to go through a couple of them with you before you get into your groups. So we are going to be doing mole conversions. And for this, there is a posting in our Google Class, which you can get to, and it has 20 different questions. So 20 questions, and it's on our Google Class. Okay, so I'm going to look at question number 2 for you. So number 2, and we're going to look at how we can go through these. So again, how many moles are in 34 grams of copper hydroxide? So, and it's copper 2 hydroxide. So therefore it has 2 hydroxides. Okay, now right beside it, it tells you what the answer is. So that is 0.35 moles. Okay, so but how do we get there? And that's what we're going to look into right now. I'm just pulling out my calculator because I forgot to get it ready. Okay, so when we go to do this, again, we're going to start with what we know. And we know that we have 34 grams of copper hydroxide, copper 2 hydroxide. Okay, so when we finish what we want to know how many moles we have. All right, so if we start out with 34 grams, what do we know we can use in order to find out how many moles we have? Well, we know that we need our molecular mass, right? And our molecular mass, or molar mass in this case, is going to be 1 times a copper and 2 oxygens and 2 hydrogens. So 1 copper, if we look it up on our periodic table, is 63.546. And 2 oxygens would be 2 multiplied by 15.9994. And 2 hydrogens multiplied by 1.00. What do we got there? 794. Okay, and again, we're going to add all of that up. And let me just do that with my calculator. If this was on the document cam, you'd see me pushing this all in, but 0.546, just let me know that you are, or you can do this on your calculator. 2 times 15.9994 plus 2 times 1.00794 equals. Okay, and I get a molecular mass of 97.56068. Now, remember, with our significant figures, we only want to keep the least significant figure, which would have happened with our copper, as in 5 significant figures or 3 decimal places when we do adding. So we literally can only keep those ones right there, in which case our molecular mass will be 97.561. Okay? So again, we're going to use this up on top. So this is kind of like a side. I know I put it right in my notes, but you can do that anywhere. You don't need to show it to me unless you're having issues with it. But we are now going to multiply by we know that we need moles on the top and we need grams on the bottom. So we're going to put our grams on the bottom, we're going to put our moles on the top, and we know that 1 mole of copper hydroxide is equal to how many grams of copper hydroxide. So when we look, we have 97.561 grams of copper hydroxide. Okay, now that is just set up fairly quickly, and if we look at our units, we've taken grams of copper hydroxide, and we now have moles of copper hydroxide. All right, we know that we are pretty good with that. So I'm just going to start on the next line just because my molar mass is in the way. And I've got X moles is equal to, and when I do that calculation, so I'm going to take 34 divided by 97.561, and I'm going to get 0.348499. Okay, but if we look at our significant figures, here we have 2 significant figures, and here we have 5 significant figures. So our answer can only have 2 significant figures. So it can only have 2, so therefore we need to round our answer, and we would get 0.35. Oh, I was about to write moles, and that is not correct. There we go. That would be moles, or I was about to do grams. Okay, so our answer then is there is 0.35 moles in 34 grams. Okay, and if you wanted to be totally technical, then you could put your little therefore statement. That's more for math, not chemistry. But if it was something that you were handing in, yes, I would want a therefore. And let me just put it there. There are 0.35 moles in 34 grams. Okay. Okay, so I said that I would do 2 for you, and I think so that is the first one. And for the second one, we're going to do question number 3. So let me just move this up a little bit. And we're going to do number 3 on the same handout, or the same number of questions. And we have how many, oops, that was a W. How many, apparently my spelling has not improved. How many moles are present in 2.5 times 10 to the 3, 23 molecules of methane. And remember that CH4 is methane. And again, we have the answer written right beside us, and we have 0.42 moles. Okay, so again, we're going to set up our question, which we need to know how many moles we have. Okay, now we know we need to start out with what we are given, and we have 2.5 times 10 to the 23rd molecules. And now we're going to look up our conversion factors, and we're going from molecules to moles. And if we look at our previous notes, we realize that that would be Avogadro's number. So we're going to use Avogadro's number, but remember that it can be used upside down or upside right, whichever way you look at it. And we have 1 mole. We know we need moles on the top. And we should probably be using our CH4s. Okay, so molecules of CH4, 1 mole of CH4. And remember that our Avogadro's number is 6.02 times 10 to the 23rd molecules of CH4. Okay, just make sure our line goes all the way over. And if we look at our units now, we have molecules and molecules, take it away, and we've now got moles of CH4, which works out perfectly for us. That's what we're looking for. Okay, so rewriting again, if we are going to look at moles, take out your calculator. And again, if this was on the doc cam, you'd see me doing this. 2.5 to the exponent 23 divided by, do I need to type in times? You could, but you can just put in the divided by 6.02 to the exponent 23 equals, and I have 0.415282392. Okay, that's a lot of significant figures. But remember, write them all down because then we can use them to round. So here we have two significant figures. And if you remember, Avogadro's number is a constant that has an infinite number of significant figures. So with our least amount of significant figures, we need two decimal places or two significant figures, and that would round. So we have 0.4, and that would round up to 2, and that would be moles of CH4. And that should have said moles of CH4. Okay? All right, and then again, if it was a test, therefore, there are 0.42 moles of methane in 2.5 times 10 to the 23rd molecules. Okay, so right now you're going to